All right, today we're diving deep into Christopher Nolan's 2014 sci-fi epic, Interstellar. This was a film that wasn't just aiming for the stars, it was trying to set a whole new standard for science in movies. You know, this quote from Quentin Tarantino just hits the nail on the head. We're talking about sheer audacity here. This wasn't just a big idea, it was a blockbuster so dedicated to getting the science right that its visual effects team, get this, actually ended up publishing peer-reviewed scientific papers. But this incredible journey through the cosmos, it actually starts right here on the ground, on a near-future Earth that's basically given up. It's being choked by blight and these massive, suffocating dust storms, and humanity has become what they call a caretaker generation, just focused on farming the one thing that will still grow: corn. And that's where we meet our hero, Cooper. He's a widowed engineer, a former NASA pilot who's now just a farmer. And he literally stumbles upon this secret last-ditch NASA mission that gives him an absolutely impossible choice. Does he stay with his kids on a dying world, or does he pilot humanity's last hope through a mysterious wormhole to find us a new home? Now, the mission has two options, and they couldn't be more different. Plan A is the one everyone's hoping for. Solve this impossible gravity equation, lift these giant space stations off Earth, and save everybody. But there's a secret. Plan B, the backup plan. And it's brutal. It means the crew finds a new planet, colonizes it with frozen embryos, and just leaves everyone on Earth behind. So to make this journey, the crew has to play by some pretty wild rules of physics. And the guy who basically wrote the rulebook for the film was Nobel laureate and executive producer Kip Thorne. Okay, so the biggest scientific idea you have to wrap your head around is something called gravitational time dilation. And this is a real thing, from Einstein's theory of general relativity. The simplest way to put it is the stronger the gravity pulling on you, the slower time moves for you compared to everybody else. It's truly mind-bending. And this isn't just some abstract theory in the movie. No way. They make it terrifyingly real. On what they call Miller's planet, which orbits this supermassive black hole named Gargantua, the gravity is so intense that for every single hour the crew is on the surface, 7 years go by for everyone else. And that, right there, is where the science just punches you in the gut. After what feels like just a few hours on that water planet, Cooper gets back to the ship and finds 23 years of video messages waiting for him. He has to watch his kids grow up, get married, have their own children, all in a few minutes. It's absolutely heartbreaking. So that commitment to science is what makes Gargantua so unforgettable. Kip Thorne literally handed the effects team pages and pages of theoretical equations. They had to write entirely new software just to accurately show how light would bend around a real black hole. The final image was so accurate, it actually gave Thorne, the Nobel Prize winner, new insights which led to 3 different scientific papers being published. That's just incredible. Now, you'd think a movie packed with this much brainy theoretical physics would be all green screens and CGI, right? Well, that's where Christopher Nolan just completely flips the script. He insisted on a hands-on, totally practical approach. Yeah, he basically said no thanks to green screens. He wanted real, tangible sets. He wanted real locations. He took the crew to actual glaciers in Iceland. And to create that dying Earth, he actually planted and grew 500 acres of corn in Canada. Talk about commitment to reality. And so much of what you see isn't just pixels. The spaceships were these huge, super detailed models. The ship interiors were full-size sets built on giant, moving gimbals. And even the robots, Tars and Case, those were 200-pound practical puppets, operated right there on set by an actor named Bill Irwin. Amazing. And this whole philosophy, this build-it-for-real idea, didn't stop with the visuals. It went all the way to the film's iconic music, which has a pretty famous and unconventional backstory. So Nolan didn't give the composer, Hans Zimmer, a script. Nope, he wrote him a 1-page letter about the relationship between a father and his child, and that's it. Based on that feeling alone, Zimmer wrote that beautiful, intimate main theme. Only then did Nolan reveal the film's cosmic scale, and they decided to use a massive 1926 church organ to give the score its breathtaking celestial voice. So here we are, a decade later. Why are we still talking about this movie so much? Let's break down its lasting impact. Well, for starters, it was a huge hit at the box office. And that proved something really important. Audiences are smart. They were hungry for big, ambitious, thought-provoking blockbusters that don't talk down to them. Critically, yeah, the plot definitely sparked some debate, but the reception was overwhelmingly strong. Pretty much everyone praised its awe-inspiring visuals and its sheer ambition, and it rightfully won the Academy Award for Best Visual Effects. But its real legacy is so much bigger than awards or box office numbers. Interstellar became a cultural event. It championed big ideas, it made practical filmmaking cool again, and it argued that the one thing that can travel across any dimension, across all of time and space, is human connection. And that leaves us with one final thought. In an age where digital effects can create literally anything we can imagine, what boundaries are actually left for filmmakers to push? What does that next great leap for science and cinema even look like?